Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 5 of AI Assisted DevOps Zero to Hero series. And in this video, we will focus on AIOps. Till now, we completed 4 episodes in this series, starting with Introduction to Gen AI, where we learned what is Gen AI and how DevOps engineers can make use of Gen AI. In episode 2, we learned about prompt engineering, what are various prompt engineering techniques, and how these techniques can enhance the DevOps engineer's productivity. In day 3, we learned about large language models, how large language models can be run locally, and we also learned how to make API calls to the local LLMs and also hosted LLMs. Especially in this video, we did our very first Gen AI project, that is how to generate Docker files using Gen AI. We used Olama and Llama 3 for this. In day 4, we learned about AI powered shell scripting. As DevOps engineers, we all write shell scripts, but using Gen AI or using AI pair programming, how we can write the same shell scripts or even better ones in less time. That is what we learned in day 4. As I told you, today we will focus on AIOps. What is AIOps? What is not AIOps? And how enterprise observability platforms such as Dynatrace, Manage Engine implement AIOps. We'll also take a look at that. Overall, this video is going to be super interesting. Make sure you watch it till the end. Let's get started. So let's first start with understanding what is not AI ops. Now, this is important because there are a lot of misconceptions around AI ops. People assume because they are using Gen AI, they are doing AI ops. Let me explain. For example, using generative AI or large language models to automate your Kubernetes deployments or your Kubernetes workflows is not considered as AIOps. Or using Gen AI to generate Docker files, again, making API calls to LLMs and generating Docker files is not considered AIOps. Similarly, CI/CD pipelines or shell scripts, these all are not considered AIOps, but they are considered as AI assisted DevOps. Or some people also call it as using Gen AI to enhance DevOps practices. Now you might ask, then Abhishek, what is AIOps? As the name suggests, AIOps is artificial intelligence for IT operations. Let me make it clear. So we will take a particular use case and understand how AIOps came into existence and what are the advantages of it. For any organization, irrespective of the domain, what's important is to have their application available and reliable at the same time. That is, their application is running 24 by 7 and the running application is working as expected. However, in the world of IT, it's very common that application does not work as expected. Maybe because application does not have enough resources such as memory, CPU, disk space, or because of the degrading performance of application, the response time of the application is slow. Maybe the ideal response time is 10 milliseconds, but application responds back in 1 second. Or also it's common that application responds back with 502 bad gateways because it fails to connect to other services, or maybe 404, 500. Different kinds of issues can lead to degrading performance of the application, which makes system not so reliable. Now you might say, but Abhishek, this problem can be solved using observability. Yes, definitely observability can solve this problem to maximum extent, and AIOps is also related to observability, or you can consider it enhances your observability. Let me explain how. So when you set up observability stack, so you all know there are three pillars of observability. You have metrics through which you can monitor the system. You have logs and traces. So once you set up observability stack, what you can do is, probably if you take this example or the use case where application runs out of memory, to avoid this, what you can do is you can set up a monitor, and this monitor continuously looks at the metrics, that is the historical memory, and whenever the memory or RAM reaches 80% or 90%, what you can do in your monitor is you can configure an alert. So you can tell your observability system, let's say you're using Prometheus for monitoring. So you can tell Prometheus that whenever memory reaches 80%, just shoot an alert. And this alert can be sent to Slack, or it can be sent to PagerDuty, or it can be sent to email. Now, once the respective team, let's say DevOps engineering or SRE team, once they get this notification on Slack or email, what they do is they react to the issue. So what is observability doing here? So it is setting up a reactive approach. So it's an internal feedback system which continuously gives you feedback about the state of your system through monitors, logs, and traces. And it can help you avoid the situation of your application going down by creating a reactive approach, that is sending emails or Slack notifications. However, imagine a scenario. You got the notification that the CPU utilization is 80%, but by the time you log in, the CPU utilization has reached 100%. And by the time you understand what has happened, because sometimes issues are not straightforward. It's not that you see the CPU of the node as 80% and you try to increase the CPU. Maybe you're using an auto scaling and it's not that easy to increase the CPU, or the CPU throttling is happening, or maybe if you consider memory, even though you increase the memory, maybe your application is continuously leaking the memory. You increase 2 GB, but after 2 to 3 hours, again, it reached 90%. So it's not very easy all the times that you receive the notification and you fix the issue. It's quite possible that by the time you address the issue, memory has reached 100% and customer ran into downtime. So even though you have the reactive approach where observability stack does all of this for you, you might still incur downtime or non-reliability of the application. So what can help you? What can help you is a predictive approach. What if, you know, definitely having all of this is good. What if additionally, on top of your observability, you have a predictive approach where someone can predict that maybe on 25th of March, you can expect 10,000 more customers, and because of which your application can receive 10,000 more requests. So the memory might reach 90%. Or how about someone can predict that I see an anomaly in your memory usage or in the application memory usage. What is anomaly? A strange behavior or a strange pattern. So if someone can tell you that for the service, the memory spike is happening very rapidly, and maybe after 10 days, it might hit 80% of memory that is allocated to the virtual machine. Now, if you have this predictive approach, this can help you not even reach to this point. So over the midnight, you don't have to receive a Slack notification. Over the midnight, you don't have to log in and try to fix the issue, because there is a predictive approach, or someone is predicting by looking at your observability stack, by looking at your monitors, that something might happen in future. And this particular thing is called as AIOps. So AI for IT operations. Now, where does AI come into the picture? You can clearly notice we were talking about prediction, and who can do the prediction better? AI can do the prediction better. Even in the first lecture of this series, I was talking about traditional AI versus generative AI. And I told you one of the primary purpose of traditional AI is to predict. We took weather reporting application as an example, and it fits even this example better. If you look at weather prediction applications, what do they usually do? So they take historical data of all the locations, right? So they take historical data of, let's say, New York, they take historical data of Delhi, Hyderabad, they take historical data of states in different countries, and they feed that historical data to the AI models that they developed. And what these AI models do, typically, we are talking about traditional AI. And what these traditional AI models can do, when you provide them with good amount of data, they can identify the patterns, and they can predict what is going to happen. Now, the prediction cannot be 100% right, but it's definitely better than what a human can predict. So this is how weather prediction applications can actually tell you that, okay, I believe looking at the last 50 years of historical data of New York, or over the last 10 years, this is how the climate of New York is. And I can sense some abnormalities during a particular month, that is maybe March. And because of that, I predict temperature on 25th of March is maybe 10 degrees. Similarly, just like how weather prediction applications using traditional AI can predict something that's going to happen, even when it comes to observability. So when you're dealing with observability, you are dealing with tons of data. You got the data from metrics, you have the data from various dashboards that you have set up, logs, you have data that's coming to you from traces. So because huge amount of data is fed, observability stacks can develop traditional AI models. So they can develop their own AI models, which can look into the data and predict the patterns. You might say, Abhishek, but I can also look into the data. So you said here that if the CPU utilization is 80%, then an alert is fired. Instead of going for AIOps solution, because these observability platforms are going to charge me. So instead of taking a subscription of that, as a DevOps engineer, I will continuously look at the dashboards, or I'll set up a huge monitor in my organization, and everybody will start looking at the monitors. Now, this will work when you have a small company and when you have small number of services. Imagine MNC that is dealing with thousands of services, or even if you consider 100 services, there are at least 10,000 metrics that you have to monitor. Now, if you are ready to monitor 10,000 metrics, such as CPU, memory, response time, HTTP status code for each of the services, then you can ignore the AIOps solution. But if you want AI to predict the patterns, maybe one of the application from morning 6 a.m. to 7 a.m. every day in the morning because of more user requests or because of anything. So a pattern is observed within that particular service that morning 6 a.m. to 7 a.m. there is a strange spike in the memory. And every day this spike is going high. So your AI can tell you that this is something that you have to watch for. Just do not only worry about the monitors or the alerts that you're getting. On top of that, this is something that might affect you in the next 10 days, right? So this is where AIOps came into picture. Overall, what AIOps does, it tries to address your IT operations. Specifically, it is more important in the space of observability because there is huge amount of data and AI performs when data is better. Now, Abhishek, is there no role of Gen AI when it comes to AIOps? Honestly, if you consider 2 to 3 years back, AIOps solutions are mostly based on traditional AI. But now, some of the observability platforms, what they are trying to do is they are trying to blend or they are trying to use both Gen AI and traditional AI to enhance their AIOps solutions. How? For example, if you take this use case here, traditional AI predicts that there is a memory spike. What Gen AI can do, it can take instruction from the traditional AI and it can react to the situation. Instead of a human reacting to the situation, you can place a AI agent, right? So let me explain. Traditional AI predicts the situation. It predicts that memory spike in the next 10 days might bring your application down. Gen AI takes this input. So you can place a AI agent or even observability platforms can develop AI agent. Traditional AI sends input to the AI agent and AI agent reacts to the situation without any human intervention. What Gen AI can do here, that the AI agent, it can go to your carpenter or it can go to your auto scaling group and it can instruct that to create a new node or it can instruct that to enhance the memory. Carpenter will do it, but only when carpenter sees that the memory is 80%. But A agent can instruct the carpenter that, hey, I know something is going to happen. So just enhance the CPU or enhance the memory. So this is the solution that few observability platforms are working on. However, not I looked at various observability platforms. Right now, this solution is not that efficient. Maybe in future, this solution might be efficient. So this is about AIOps and how AIOps works in real time. I hope you got what is not AIOps and what is AIOps. Now let's see how enterprise observability platforms are implementing AIOps in their observability stack. One thing to remember, AIOps solutions are usually not free. For example, if you take Grafana, it's not part of the free Grafana offering. It's part of Grafana Cloud. Similarly, Datadog, Dynatrace, Manage Engine, because AIOps is a solution where companies need to develop their own training models and they have to continuously retrain it. It needs infrastructure to run. Because of multiple reasons, companies want to keep it proprietary. Of course, there are few open source offering on GitHub, but the efficiency of those solutions is not that efficient. So either you need to develop your AIOps solution, which requires you to develop a complete ML model as per the requirement, train the model, and get it worked, or use enterprise observability platforms. We will see Dynatrace and Manage Engine in this video. Luckily, both of them provide playground environment. So it's like a free playground environment. You can just sign up to those playground environments and you can get a feel how AIOps solution works. I'll just walk you through them. But if you also want to get hands-on of this, use the links in the description. I'll put both Dynatrace as well as Manage Engine. So if you go to Dynatrace and you just search for AIOps, you will find this dashboard. As I told you, what AIOps solution does, it feeds on traditional observability data. So you can just create a monitoring dashboard and you can feed that as an input to AIOps. AIOps is just an offering. In Dynatrace, they have an offering called Davis. So you can just provide the monitoring dashboard as an input to your Davis anomaly detector or Davis AIOps solution. So they have created few dashboards so that you can get a feel of AIOps. The first one is order related thing. So let's say there is a e-commerce company. Okay. Assume there is a e-commerce company which deals with order volumes. So it is a metric, right? If you take e-commerce companies like Amazon, number of orders that they receive on a particular date is a metric. So you can collect historical data of it. For example, number of orders received on 24th of March. Number of orders received on, let's say, 24th of February, 25th of February. Similarly, 26th. So you can collect 1 month of historical data up to, let's say, 23rd of March. Create a dashboard for this metric, right? Or set up monitoring for this metric and feed that to AIOps. That's what they have done in this dashboard. And you can see here clearly. So this is the graph for 18th March, where orders packed are 33. And then you can see on 19th March, it came down, it is 13. On 20th of March, orders packed are 27. Similarly, 13. So the Davis platform, it understood the orders packed for last 30 days or something, and then it starts predicting. So the ones in blue here are the prediction. So you can see that on 25th of March, it predicts that the orders packed can be up to 63. And similarly, on 26th of March, the orders packed can be a very less number. So it can be 18. So how does it predict? It takes previous historical data, performs machine learning algorithms or the predictive analysis, and it tells you what can be the orders on 25th, 26th, 27th going ahead. Just like how the stock market works. So it is all about forecasting. And there are other dashboards as well, not only this one. So this is one metric which is related to e-commerce application. If you are working in an e-commerce company, this might help you. Similarly, predictive capacity for available disk. So this is another dashboard that they have set up. And similar to the previous one, here you have historical data of 19th, 21st, 23rd. Because this is a flat curve, the disk space has not gone up, utilization has not gone down. So even the Davis predicts that on 25th, 27th, it can be the flat line. Because there are no anomalies, right? Anomaly is a sudden spike or any unexpected behavior. Disk space is always constant. So that's why on 25th, 27th also, the disk space is constant. The forecasting is constant. This is predictive incident response. This is Kubernetes CPU usage, Kubernetes memory working sets. So you can just go through these dashboards and explore it yourself as well. Just like this is one observability platform, that is Dynatrace. Similarly, Manage Engine also has an anomaly predictor or AIOps solution, which is called as Zia. So Zia anomaly dashboard also feeds on metrics, monitoring, and dashboards as input. So they have set up different metrics. For example, they are monitoring this REST API and it says there is one likely anomaly. I can show you in detail. So if I duplicate this tab, if we just look at the metrics that they are monitoring. So they have set up 1085 monitors, and all of these monitors are fed as input to Zia anomaly dashboard or AOP solution. And it says out of 1085 monitors, 66 of them have confirmed anomalies. So it's very simple. It's plug and play. Just connect that to your AOP solution. And it says out of 1085, there are 66 confirmed anomalies. What are these 66 confirmed anomalies? These are the ones. If you just go to one of them and try to expand. So for example, here it says monitoring group demo. It has 3 confirmed anomalies. Or if you go to this one, homepage of a particular website, it has one anomaly. And if you try to read more about it, it says the page load time. We talked early in the video, one of the metrics can be HTTP response time or application response. So here it says page load time has surged by 15609 milliseconds in Canberra. So it says for a particular region, and it is 1.9 times more than the usual thing. And it also says that it happens between 12 a.m. and 10 a.m. So you can take this as an alert and you can react to it. Now, what is the next step that you can do? Typically, what is the next step that this observability platform can do is they can develop an AI agent, and then it becomes traditional AI plus Gen AI solution. So imagine they have a button here, which is a Gen AI solution. Maybe let's call it as Zia Gen AI. And when you click on it, it takes the input from here where the page load time has searched. So this Gen AI solution will read it and it will go to the application or infrastructure and try to fix it. So that is where Gen AI comes into picture. And most of these observability platforms, they haven't integrated Gen AI or they might be working on it. Once you have it, this becomes an end-to-end user experience. And that will be true power of AIOps with a combination of traditional AI and Gen AI. Let's wait for that. However, I hope you found this video informative. I hope you understood what is AIOps, what is not AIOps. I tried a lot to set up a open source solution so that I can show you how to integrate it with Prometheus or something, but none of the AIOps solutions were that efficient. So I had to get the playground environments and show you how AIOps can be set up and how it works. See you all in the next video and let me know if you have any questions in the comment section. Take care. Bye bye, everyone.